Hello, we are discussing about GATE 2006 ECE paper. Look at the system shown where x of t is equal to sin t into u of t, and in steady state what is the response y of t. Okay, so look at this one. If you are going with a system and let us assume you are giving x of t as going to be input and output of the system is y of t. If the system consisting of 2 itself, the meaning is y of t is equal to 2 times of x of t. So if x of t is equal to sin omega t, then y of t is going to be 2 sin omega t. If x of t is equal to sin, okay, omega can be input signal frequency. Sin omega t means omega means signal frequency. A single signal frequency component you are applying, that is sin omega t, that frequency is omega. So if you are applying sin 10t, you will get it as 2 sin 10t. If you are applying sin 100t, then you are going to get it as 2 sin 100t. Because the function what we have taken, the system is having a constant function. Instead of this one, if it is having 1 by s plus 1, okay, as given in our system, s is nothing but j omega, so you can write it as j omega plus 1. Now the system consisting of, okay, 1 by j omega plus 1 as its transfer function. Now the system transfer function is related to omega, is a function of omega, where omega is input signal frequency. So each signal is going to be amplified differently because depending on the input signal frequency. Since system is going to be depends on, since system transfer function, say it as h of j omega. Since system transfer function previously it was constant, so it doesn't depend on the input signal directly. Whatever the input signal you have given, that is multiplied by a constant. But now since h of j omega depends on omega, where omega is input signal frequency. So as the input signal frequency changes, the magnitude given by this transfer function, that is system, as well as phase angle will also changes. So gain and phase angle, that is magnitude and phase angle of the system offered for the signal, depends on the input signal frequency. As the signal frequency changes, magnitude as well as phase angle also changes. So y of t will be different for different frequency signals. Now we are going to calculate y of t whenever x of t is equal to sin t. Sin t means if you are equating it to sin omega t general equation, then from this one you can say omega is equal to 1 radian per second. By comparing general sine equation with given sine, then we can identify omega is 1 radian per second. That is, now the input signal frequency is constant, that is 1 radian per second. At this frequency, what is the gain offered by the system as well as what is the phase angle offered by the system? If we know, that has to be multiplied with the input signal to get the response y of t. Okay, so at omega is equal to 1, we are going to calculate gain, magnitude and phase angle offered by system, that we are going to calculate. So that is nothing but sigma h of j omega and h of j omega angle at omega is equal to 1 radian per second. We are going to calculate, then we can write the y of t. Okay, so now h of j omega is equal to 1 by j omega plus 1. So from this one you can write it as magnitude of h of j omega is equal to 1 by under root of omega square plus 1, and that too at omega is equal to 1. We can write it as omega is equal to replacing with 1, so that it will be root 2, and phase angle of h of j omega is equal to minus tan inverse of, because it is denominator, so that if it is coming up at that time it will be minus tan inverse imaginary by real, so that omega by 1, and omega is replacing with 1, okay, because input signal frequency is 1 radian per second. So tan inverse minus tan inverse 1, which is nothing but minus pi by 4. So x of t, that is sin t, is going to be offered a magnitude of 1 by root 2 and a phase shift of minus pi by 4. So your output is going to be 1 by root 2 times of sin t minus pi by 4. This you can write. So 1 by root 2 is the magnitude and pi by 4 is the shift. So that is the right answer is nothing but A. A is the right answer for the given question.